Electric vehicles are rolling computers, and sometimes a fix for a drivability complaint, charging issue, or warning light doesn't involve a wrench at all. It involves a laptop, a scan tool, and a software update. That's a major shift for technicians who grew up replacing parts first and programming second. But in today's EV world, software is often the repair. Electric vehicles rely heavily on module communication and software logic. Nearly every major system is electronically controlled. Battery management systems, charging systems, thermal management, regenerative braking, inverter controls, even door handles and lighting strategies are all managed through software. Unlike older vehicles that relied more heavily on standalone mechanical operation, EVs constantly make decisions based on programming, and manufacturers are learning in real time. That's the key technicians need to understand. Many EV platforms are still evolving after the vehicle leaves the factory. Automakers collect huge amounts of operational data from vehicles in the field. If they discover a charging strategy that causes premature battery stress, or a thermal management calibration that hurts range in cold weather, they can often correct it with updated software instead of redesigning hardware. Tesla became famous for this approach, but now nearly every manufacturer is doing it. Ford, GM, Hyundai, Volkswagen, Rivian, BMW, they all release software updates to address drivability concerns, charging performance, battery conditioning, false warning messages, and even brake feel. Some updates are customer-facing over-the-air updates. Others require dealer-level or aftermarket-capable scan tools connected through factory service software. And here's where technicians can save themselves a ton of diagnostic headaches. Before condemning expensive EV components, always check for software updates, technical service bulletins, and module calibration revisions. You could spend hours diagnosing a system that engineering already fixed 6 months ago with revised programming. There have been cases where EVs experienced reduced charging speeds simply because the charging curve calibration was too aggressive. Some vehicles had false isolation fault warnings triggered by software sensitivity issues. Others had battery range concerns corrected by improved battery management calculations. No parts replaced, no torn apart battery pack, just updated software. That doesn't mean software fixes everything, of course. Hardware failures still happen. Cooling pumps fail, contactors stick, high voltage cables can become damaged. But modern diagnostics require technicians to think digitally first before mechanically. And honestly, this trend isn't slowing down. As vehicles become more connected and software driven, technicians are becoming part mechanic and part IT specialist. Shops that understand programming, module initialization, and software calibration procedures are going to have a huge advantage moving forward, because sometimes the most important tool in the shop isn't a socket set anymore. It's a stable internet connection and the ability to properly update a vehicle software without turning a perfectly good EV into a very expensive paperweight. Thanks for watching, and we'll see you on the next one.